I am, however, Eric Anderson for Atlantic Data Security, here with another support-aware webinar. What is that? Who is that? What is this all about? Well, that's where we start. And I'm going to go to the first slide. For those of you who don't know who we are, first of all, how? Most of you should know who Atlantic Data Security is, because most of you are our clients, our customers, our contacts, people we work with. And that's why you're here. Some others sometimes find their way here as well. So welcome to everyone. We are, for those who don't know, even if you do know who we are a premier cybersecurity solution provider. What does that mean? Well, anyone who's talked to me has heard me say it's about the value add, not the reseller. The key is we try to make sure that our clients, those who we work with, are getting value out of not just products, but services, and positioning themselves better in the world of cybersecurity to deal with that nasty landscape out there and deal with threats and so forth. Whether that's through finding the right fit with products and solutions with our vendors that we very selectively partner with, or whether that's through services using our ever-growing and always impressing me in our capacity and knowledge, our engineering team. We are focused primarily in these events on Check Point, not entirely, but in this you'll see when we get technical and when we actually get down to nuts and bolts, we're talking Check Point here because the vast majority of our clients are using Check Point. And that's kind of the main focal audience here, but not exclusive. We'll try and have a little something for everyone, but that is, without getting into pitching and vendors, that's really the primary focus of our support-aware offering, partly because we are an elite partner with Check Point. There aren't that many. I don't know what the count is, but I believe I can indicate them all with less than one hand in the States here. We are the only one, however, that's also a managed security provider, managed service provider, and an authorized training center. That's something we have been for a long time. I've been an instructor for Check Point for, I think I can say 20 years now or close to it. And those are some of the things we do. But again, the goal is to have a large team, which we've got with a high level of expertise and experience around Check Point, as well as all of these other products that we're doing more and more work with. So enough on that. What is support aware? The next question. Well, support aware is one of our offerings, and it's really kind of a bundle of offerings, very hard to explain in a simple slide, so I'm not going to linger on it, and I don't want to sell you anything anyway. Most of you are support aware clients of ours, and that's why you're invited here. This is part of the benefits as we try and further education and deliver free training and so forth. But all these things, and I'm not going to dive into all of them, but the idea of adding services at a contract or a regular level and being able to help you augment either your staff or your expertise or your knowledge in ways of having our service team be available to you to do the things that we're seeing a lot more of and doing a lot more, when especially it's just a fraction of what you do. Staying on top of it can be difficult. Doing upgrades, especially when we talk about our 8040, which we're going to in a little while, getting you there is one of the things we spend a lot of our time with, is trying to help make sure that clients are keeping up to date, getting up to date to take advantage of the things that we will talk about very soon. We also this year introduced our service desk, which is a little bit more of a proactive co-management type of solution. The idea being we can more regularly and readily augment you, not just with an engineer, but with a team, with a large team of significant expertise to help in all those components, again, for the life cycle and managing your security with you or potentially for you. This, as I said, however, is a support-aware webinar. This is something that we try to do quarterly. Usually works out to have at least one a quarter, sometimes not. Sometimes we might go more than one a quarter. But the intent of these webinars is not to sell you anything. You will not see a logo other than Atlantic Data Security unless you look in screenshots and maybe catch a logo here or there. We're not trying to pitch anything to you. I'm not trying to, and this is rare, I know. We're not trying to tell you why you need this product you don't have. What we're trying to do is show you how to use what you do have or understand concepts and things that we see a lot of interest in within our customer base, within our clientele. We want to help you be able to take better advantage of what you've got. If that sometimes means you need something else, that might be the case, but that's not our goal. My goal here as an educator is to try and further your education. As far as what's on the calendar, we always have events on our events page on our website. We've got all kinds of stuff. Donna and the team and our marketing department and the rest of our organization is constantly trying to keep things going during this work from home era. There's been plenty going on in the past. There's more coming up. Definitely take a look at our website. Pay attention to the email you get from us. Don't junk mail us. Don't other us. Keep us in the focused inbox and pay attention, or you might miss things like this. As far as what's coming up next, we have a training class in the next couple of weeks, another regularly scheduled CCSA, CCSE bundle. But as far as support aware, we are planning to have our next quarterly event be in most likely January, towards the end of January. Don't have a date for that yet because we don't have finalized dates for CPX. And what we typically like to do is at the end of Q1 or for the Q1 webinar is to give a recap of CPX for those who weren't able to attend or who just didn't attend any of the informational sessions, as sometimes happens. Since we don't know exactly when that's going to be yet, we won't put up a date, but that's our most likely topic for next quarter. As far as CPX, if you haven't heard, it is, I believe, finalized that it's going to be entirely virtualized this year, which will be interesting. Could make it huge because traditionally there have been multiple events in multiple regions. And they're going to make it all one big giant virtual party. So it's going to be a new thing, but we'll deal with it. And regardless, a lot of information will come out of that. What information? We don't know. I don't want to mention R81, but that's in EA. That's one of the definite coming things. That's something we could also cover. And I do want to mention, I'm always open to doing more of these. If we have demand, if we have interest, more than quarterly, I'd be happy to try and put more together. Maybe we do a deeper dive of what we're going to talk about today, because we're not going to get too into the weeds on the underpinnings of HTTPS. But if there's enough interest or request, we can definitely do that. We can add other topics as well. If R81 comes out before the end of the year, maybe we do something around that. But definitely give us some feedback at the end of this event, later on, down the road, 3 weeks from now. You have an idea, something you'd like to see, you think others might be interested in as well, let me know. It's definitely open to suggestions, or I'm open to suggestions. But what are we going to talk about today? Oh, good old HTTPS. What is it? What does it mean? Why do we cringe when we hear it? It's here, and we'll talk about how and why, and why that's good and bad, and why we need to be aware of it and start dealing with it if we haven't already. And the timing is great because R80.40, which is not brand new, but now it's become definitely the new baseline and the new standard release, why that has made this a much less stressful issue for us. So with that said, before I dive in, the little housekeeping things, we try and keep this well under an hour. I know your time is valuable. You're sick of Zoom. So we're going to keep this relatively short. I'm going to run at a pretty quick pace. Anyone who's taken a class from me or worked with me in the past, you know I love to take questions. I would rather sit here and answer questions all day if I could, because I know if you've asked me a question, it's something you actually care about. Instead, what I'm doing is presenting something that I've already canned and kind of put together based on a lot of questions and discussions we've had recently. And when I say we, I mean our entire engineering staff. And things that we have found to be very interesting and very commonly asked. So we're going to try and solve a lot of that and answer some questions more applicably later on. And that's really the goal, is to teach a little bit, but mostly to teach things you can actually do. And it's going to boil down to some of the stuff that R80.40 has added to make this stuff easier for us. But as to the question front, I will keep an eye on questions, but for the most part, I'm going to try and breeze through. That's one of the reasons Juan has joined me. Thank you, Juan, to be able to help answer questions in real time, or at least when we have a pause or a break, he can interrupt me, which most of you can't, at least not with your voices, interrupt me and say, hey, let's show that or add something to what I'm saying. So it's not just me here, and that's what I want to come across. So you might be able to get answers immediately. If not, I'm going to defer most of them until the end to not distract myself. But with that, what is HTTPS? And I'm not going to, and actually what I meant to go back to on the agenda, what I'm not going to do is a deep dive into HTTPS itself. We'll do a very high level discussion about it, but there's a lot of other detail out there. And this is where I said, if we want to, if there's enough interest, we can do this a little bit later on. But knowing how it actually works, while very interesting, and I love the history and the under the hood stuff. I love to get my hands dirty looking at how things actually are put together. But for most of us, when it comes to practical application, it doesn't really help much to know that. To know some of the little pieces, yes, but to know the exact differences between TLS 1.1 and 1.2, especially since now we're going to 1.3, doesn't really add much to what you'll be able to do with it. So we'll talk about very high level things, but we're not going to do the deep dive into what SNIs are and all that. Can do it later. Happy to talk about any of this offline as well. If you do have deeper questions or things that need a little bit more explanation or discussion or demonstration, we can always do that later on as well. But I'm going to go through some baselining slides here really quickly, make sure we're on the same page as far as some of this goes. Ultimately, my goal, though, is to get you to the demonstration pieces where I want to show what we can actually do, what you can all do to help deal with this nasty, cringy problem. It's not intended to be a problem. If we go back to 1994, Netscape, good old Netscape, it actually introduced HTTPS as an answer to those that were using this wonderful new invention, thanks to Al Gore, the World Wide Web, and using a web browser to access sites in a nice graphic, easy to navigate format, and potentially exchange information, not just view data, but upload data and send data and log in it and go back and forth. And doing so is a great idea, just like early internet days. It was all just open. It's all here. There were no firewalls at the beginning. We didn't need them. Why? Well, most of us didn't have access, and those who did were intending to share openly with each other. Well, the World Wide Web was this new idea. Let's host some information. Let's post some stuff out there publicly that people can click on with their newfangled mouse and navigate around and retrieve that stuff easily. Once we started to expand that use and see more sensitive information being hosted, information that either should be kept private and only be visible by the person it's intended to be seen by. We want to also authenticate that person. We realized, or they realized, something had to be done to make it a little bit more secure. HTTPS is not a new protocol. It is not a new service. It's basically HTTP, really nothing different than standard HTTP, with an encryption layer thrown on top or underneath or whatever. That's what the S is, stands for security, not SSL, but security. With that encryption layer, the idea is that now our client, whether it's a browser or some other application or whatever else you might have, what else is there besides browsers and apps, that client communicates with a server via HTTP, but does it with some sort of encryption layer wrapping it all up. All of the content is encrypted within that HTTPS connection. Now, there are pieces that are not encrypted. There are some things that can't be. For example, the IP addresses. If we're sitting outside and looking at the traffic, we see encrypted traffic. We can see that this IP is going to that IP. What we can't see is what the URL is, what the content is, the data is, who the user is, any of that stuff that's inside. So all the important stuff, all the really meaty stuff is there. There are some weaknesses in HTTPS, but they really just amount to the types of traffic, are identifying volumes of traffic, the timing, the rates of traffic. So if somebody were sniffing outside and all they could see is HTTPS traffic to an IP address they didn't know, but they could see the patterns in the packets, they might be able to identify, for example, that we're streaming data, or if it's a very slow rate of communication back and forth, that it's a more interactive kind of communication based on, again, easily identifiable information, the fact that I see the packets. I can't see what's in them, but I can see that there are a bunch. That doesn't make it weak at all. It just makes it not, like a full VPN tunnel that has all kinds of other stuff mixed in with it as well. The other thing I'll note here, SSL isn't secure. Hasn't been for a long time. That was the initial introduced back prior to 1994. Actually, when this went live, I don't think it was until 95 because SSL was found to be too insecure. It was SSL 2 that made it actually work and work somewhat reliably. But even through SSL3, using different algorithms and hash methods, they became deprecated. And that's when TLS was introduced back, I want to say, end of the 90s. Even though for many of us, it's a newer term because SSL was still around or even incorrectly used as the term for the encryption layer, even though we might have been TLS. And TLS does continue to evolve as well. Again, I'm not going to dive into how and some of the problems and challenges. TLS 1.3 you've probably heard quite a bit about. It is the newer current standard, and it is not necessarily deployed as widely as you might think. We might actually establish TLS 1.3 connection to a server that's actually 1.2 because we're just taking some shortcuts. TLS 1.3 does some neat little things to optimize how sessions are established, how they're maintained, how they're run. And it's really intended around optimization. The security in 1.2 isn't really a problem. It's not that it's insecure, and it's not that TLS 1.3 makes it so much more secure. It just kind of advances things to make things a little quicker and lighter weight. But of course, it adds a little challenge for solutions to decrypting or inspecting 1.3. So let's move on from this. Again, basics, we could spend all day on these topics, but they're not as practical or applicable to things that we can actually do. So what is so good about HTTPS? If this looks familiar, I didn't really borrow or steal this content, but we had this discussion in years past when we had to explain what a VPN was all about and why they were good and what they were intended to do. The whole idea of a VPN is, again, to ensure these three things: ensure privacy, integrity, and authenticity. And if we can do that, if we can ensure that we have all of these three things maintained between communications between me and you, even if it's over a public medium like the internet, then I can rest assured that I'm not compromised. That's really what HTTPS does. It maintains all of these aspects within a connection between a client and some sort of server. That's one of the big differences. It's more like a remote access VPN in that sense, where it's a client establishing a connection to a server, typically in that direction. Now, there can be bidirectional HTTPS. There can be SSL and or TLS communications that go both ways. It can get a little bit funky, especially when you talk about VPNs that use SSL or really TLS as a shim. But the basic idea is, yes, this is all good. These are good things in a scary world with lots of prying eyes and lots of people trying to steal our data and get at us. These things are good. They can be used and are intended to be used for good purposes, to keep our private data private. That's really the main idea, and that's a good thing, right? Well, it's good when we're using it to evade the bad guys. We really want to make sure that our privacy is ensured, if not guaranteed, at least ensured or attempted or maintained when we're doing the things we're supposed to be doing. Where it becomes a bit of a challenge is when we now realize, if the bad guys can't see me, neither can the supposedly good guys. Now, it's not getting into politics here and whether we think the NSA should have the power they do or should be doing the things they're doing, but it's also become a great way to hide traffic from others who aren't necessarily out to get us, at least not as visibly and noticeably. An early example is ISPs. When ISPs were trying to throttle data many years ago and trying to limit bandwidth and keep us from doing things that they wanted us to be paying them for cable for, to buy their TV instead of streaming it. That's all fortunately changed, but ISPs can't see where we're going, track us as well, inject their own ads. Again, avoiding politics, reminding myself to avoid discussions about network neutrality or net neutrality and that, but also potentially government. Again, NSA, what are they seeing? What are they doing? I'd rather they not see any of it. So if I can guarantee privacy, integrity, and authenticity between me and whatever site that is that I'm going to, that's great. And what we've also seen, what's likely near and dear to many of us on this call, is the employer. My organization that I'm working for, or working with, or sitting behind. If I tunnel my traffic through HTTPS, they can't see what I'm doing either. Ha ha ha. Evil grin, evil laugh, rubs his hands together, which you can't see. But that's become one of those problems. this is where we get into the bad. The challenge for us, we maybe want to be those prying eyes, but maybe want to do it for the right reasons. It's really all about intent. HTTPS helps evade all of that visibility that we might be using to help ensure compliance from traffic leaving from, or entering to our organization, ensuring appropriate use by our employees or by our students, even more importantly in some cases, and also providing all the many layers and or blades in the Check Point case of threat prevention. If I want to protect you from viruses, I have to look at your content. I have to look at it unencrypted. I have to do inspection on it when it's in the clear. And if it's encrypted all the way from the server to your browser, I can't do that. However, SSL or TLS or HTTPS, really more importantly, works. It's good. It's effective. It does what it's supposed to do. We should not be able to break it. And I always like to preface this when we have discussions about HTTPS and trying to inspect the traffic and trying to do the good things we're trying to do at the top there. We shouldn't be able to. The whole intent is that the client can encrypt the traffic to the server, meaning anyone in the middle doesn't have visibility. And it works at that. It's successful. There are methods we're going to talk about to help break that. But in theory, in a perfect world, they wouldn't actually be possible. There'd be no way. We couldn't break HTTPS. We shouldn't be able to easily, but we'll talk about that again in a second. As opposed to, in terms of how vital or how, let's say, what's the word I'm looking for? Of course, I'm blanking on the word, but how prevalent, let's say, HTTPS is, there's all kinds of statistics out there. I don't like using statistics in these that I haven't verified or compiled myself because they often conflict. I can find a stat for you that says more than 50% of traffic's encrypted. You can probably find one that says it's less. There's all kinds of conflicting statistics, and rather than bore you with a lot of that, there's plenty you can find. Again, happy to take it offline. I can show you some sites that do some really cool things to show you this. A lot of them are trying to sell you something though. Google, however, has a very simple transparency report. I want to say it's transparencyreport.google.com that they've had out there for a number of years. And they do some really interesting things on that site to show you what they're seeing in basic statistics, just web traffic in general. To their servers, to google.com sites is one thing they can track. And one of the statistics I was able to get is HTTPS traffic to their sites is well over 95%. It depends, and it can be broken down on individual sites. I want to say Gmail is 100. I don't think you can get to Gmail without encrypting the traffic right now. But other sites like the portal site, the search site itself might be a little less, but it's still over 95%. That's because they redirect you to HTTPS. If you try and go as HTTP, you get a redirect, and they want to direct you to the encrypted version of the site. Again, that's not a bad thing. We're keeping data private. Is it really necessary? Yeah. One of the early workarounds to this problem was not to allow HTTPS. If we don't let you submit or send encrypted traffic, then you have to do it in the clear, and sites would allow it. Another interesting statistic I pulled out of there from specifically their HTTPS numbers is that of the top 100 traffic generating sites, which are responsible for 25% of web traffic, which I found that alone was pretty interesting. There's sites up there like Reddit and of course Netflix and other common, very busy talkers. But 97%, or sorry, yeah, well, yes, 97% of the top 100, which happens to be 97 of them, do default to HTTPS versions of their site. So most of the web traffic out there is going to default to trying to use HTTPS. We've also seen it on the client end itself, where most browsers now, instead of just showing you a web page, when you look at the URL up in the top of the browser, it's not just simply going to show you the name of the site. It will show you a nice little lock icon if it's encrypted. It used to be, if it wasn't encrypted, it either showed you no lock or showed you an unlocked padlock icon. Now, they typically say not secure. They're right in your face about it. Say, yep, this is not an HTTPS site. It is not secure. Trying to kind of entice you to not do anything, not submit anything, which kind of indicates that our presumption is that most of our traffic is secure. And that is scary, and it's a little bit bad. Always be on the lookout, be on guard, but most traffic is encrypted, and most browsers will show you if it's not. They will also protect you from connecting to sites that aren't encrypted properly, and that's part of the challenge for us as well. If you do connect to a site that is compromised, certificates are not valid, they will warn you of this, and we'll talk about that again in a little bit. One of the things I also have been asked and shown a number of people over the years, it's hard to find a site that isn't encrypted. There's 3 of the top 100 don't default to it, so you can go with just HTTP. My favorite, however, simple little site, neverssl.com. Not a plug for anybody. They don't sell anything, but their intent is to always be port 80 unencrypted for a number of reasons. One of the simple ones years ago was it was a little bit harder sometimes to connect to a wireless portal, let's say at Starbucks or an airport or wherever. If your default homepage was HTTPS and that hotspot that you connected to tries to redirect you to their page to do a login, you can't really redirect HTTPS traffic. It's not quite that simple. You can't capture it and redirect it for reasons that we said. It works. It does what it's supposed to do. It's not easy to break into. So you'd actually have to connect initially to an HTTP site, and it wasn't always easy to do or even find one. NeverSSL, one of my uses for them years ago was simply to go there, kick off that initial unencrypted web connection, get the redirect to that hotspot's login page, allow me to click whatever I have to click, and then I'm good to go. Still there, and they intend to be for a while. Kind of a cute little talk about the simplest of all possible websites. The whole idea, however, again, this is all working. It all works very, very well, but we want to see it for the right reasons. We want to be able to do things to help secure our users, help secure our organization, help secure our traffic, help ensure that things are not violating compliance, that they're not violating our best practices, and that the content they're getting is secure. And again, threat prevention has a whole bunch under it that I could list as bullets, but I don't want to make the bullets all that small. And likely you've all heard it. If you haven't, we should talk anyway. But that's the idea. We want to look at it to do good things, not to violate your privacy. At least I hope that we're having the high level discussion right now. But again, as I mentioned earlier, if it were easy, what would be the point? It wouldn't be popular. We would have moved on to something else. If it was breakable, if I could get into HTTPS without any pain, we wouldn't be using it. You wouldn't be trusting it. So again, no pain, no gain. There's got to be something. There's got to be something that we have to compromise to be able to get visibility and get insight. That's what we're trying to minimize. We want to make it as easy as possible. We want to allow you to see what's inside that encrypted traffic, to be able to secure what's inside that encrypted traffic, but not have to go to great lengths. And I'm going to do something that I might get slapped on the wrist for at some point, or people might complain about or disagree with or not like, but I'm going to simplify this. The methods we have to gain that visibility come down to 2 simple concepts, 2 very simple basic ideas. We've got either endpoint visibility or gateway visibility. We can either sit on your device, we can sit on your laptop, on your desktop, behind your browser, so that once you've decrypted the data in your browser, SSL or HTTPS was not compromised. We allowed it to inspect, decrypt, see everything it needed to on its own without anybody else gaining visibility, private connection between the browser and the server. But once you're decrypted by the browser, now maybe we have software that can see it here. That's one method. This goes back to the good old days. This goes back to, and I'm going to go to my next slide because I'll go into each of these in a little bit more detail, but this goes back to the idea of gateway antivirus versus desktop antivirus. We had those discussions many, many years ago, which is better. And the proper answer was always both together. Depth is great, because not everything is going to be seen at the gateway. What if a user brings in a thumb drive or brings a laptop home? So we want to have stuff on the endpoint. Well, that's one of the ways to get visibility into encrypted traffic, is see it after it's been decrypted. The other thing that we see at the client level, at the endpoint level, and this one's a little bit harder to always relate back to this, is the idea of tunneling my traffic not directly to the site I'm going to, but to somebody else in the cloud. And this is not a brand new idea, but it's really gaining a lot of steam. And make no mistakes, and I don't want to anger vendors that we work with and disrespect their products and their concepts and some amazing technologies and great things that are going on. That's why I'm not putting logos up here. Again, that would also make it a salesy presentation. But basic ideas of CASB and a lot of the other solutions we see involve a client. It's not so much that we're sitting with antivirus software monitoring the content that comes out of the browser, but we're, instead of actually having our browser connect from my client device directly to gmail.com, I am instead tunneling my traffic to some other broker who is decrypting it, who is then potentially securing it, analyzing it, inspecting it, and sending it off to gmail.com. It's effectively like what we're going to talk about in the next section and spend most of our time on today, that idea of being a man in the middle. They're just an authorized man in the middle. I've put software on my computer, on my laptop, on my tablet, my phone, that is given the permission to work with and be that man in the middle. But I'm doing it at a client deployment level. The issue we've often had with deploying endpoint software is just that. I've got to touch a whole bunch of devices. It's not always practical or possible to get that software onto all the devices that I want to secure, especially when you go to certain sections like, or certain verticals like education. If you're higher ed, especially when you don't own or maintain or have any access to the devices that are using your network, you don't have any ability to deploy anything, and usually don't have the ability to force anything on them. That gets very difficult, and they are going to be a problematic group. I'm not going to give you a magic bullet because it doesn't exist. I think I mentioned on the last slide, there isn't one. There is no magic bullet that makes this easy. But doing things on the client or somewhere in between where we have some form of software, whether it's fat or very, very thin, something that allows the client to either do the inspection itself or tunnel the traffic to a trusted broker that can do the inspection and add the value, or decrypt and send it to another broker who's actually doing something else to look at the data. And we see both of these. Again, I don't want to get into logos. I will mention products like iBoss, and there are some others that intend to simply allow us to pull apart the HTTPS with that authorized client software with an authorized broker to then potentially be inspected by yet another product, but be inspected in the clear. And that other product doesn't even have to know that it was originally encrypted, and then they'll re-encrypt it again on the other side. There's some really interesting things going on there. But again, this is not in our scope today. This involves product. This involves deployment. Happy to talk about it. Happy to work with clients to figure out what the best solutions might be in this way, in this area. And it's definitely a growing space. There's a lot of solutions here. So definitely engage us, and we can get into the more salesy, but still kind of consultative type discussion on what we can do with the client end. I want to focus more today on what we can do and what most of you can do, especially if you're Checkpoint customers with Checkpoint gateways, to actually be a man in the middle, but be a man in the middle for the right reasons. That's basically what we're talking about. Man in the middle, you might have heard many, many years ago, always ended with the word attack. The basic idea here is I could be sitting somewhere else, not on your network, not authorized, again, gain access to your ISP or somewhere along the path of where you're going, or simply use redirects. You type the wrong URL, you end up hitting my site before the site you really want to. What I'm basically doing is transparently proxying your traffic. Your connection terminates at my site. I say, oh yeah. Welcome to Gmail. I actually go and make a new connection out to Gmail, pull down the content, and then deliver it to you within your session with me. So now you're getting what looks like Gmail, but you're getting it from gfail.com because you fat fingered the URL. That's the basic idea of the man in the middle from an attack perspective, is I can receive that. Now all the data you send to Gmail is actually going to gfail. I'm going to take it. Maybe I'm going to deliver it on to Gmail, pull that content back, just like ATM skimmers used to, if you remember that idea. And they do still show up every now and then. You'll see a story where somebody puts their own facade in front of an ATM. You slide your card in. It slides right through their device and right into the real ATM behind it. They were able to read your magnetic strip. Simple enough. Passes it through the ATM, read your magnetic strip, and you're actually looking at the screen that belongs to the real ATM. The keypad, however, that you're typing on is simply pushing the keys underneath it on the real ATM, but they're also now logging the keys that you press, potentially logging the entire session. So now what they've got is your magnetic strip. They've got your PIN. They can now make their own card and they have your PIN. They can go do whatever they want with it. And that was the basic idea. That's what a man in the middle does. He's that skimmer sitting in between, potentially retrieving the data or getting data from you, sending it on, delivering it back and forth. Again, it's really just like a proxy. It's just one that's transparent. There are mechanisms put into TLS and even more specifically or more importantly into HTTPS to help deal with this and avoid this. Most of the challenge comes down to certificates. That's the primary method used to validate and verify that the server I'm talking to, that I think I'm talking to, is the server that I want to talk to. And that's, again, a good thing primarily, but it's also what causes us some grief. If I were to log into gmail.com, but my traffic were intercepted by gfail.com because I typed the wrong URL, the certificate I get is going to match gfail.com, but the page itself that I connect to and retrieve might know and be able to tell me you're not getting the right cert. You're on the wrong page. You went to the wrong place, dummy, and show me that the cert isn't really valid for the content I'm getting. That's where we can help expose that man in the middle. That's again, a good thing. But if we're trying to do it for the right reasons, how do we deal with that? How do we mitigate that? How do we understand what traffic we can or should and shouldn't decrypt? Ultimately, we need to make exceptions. How do we do it? Well, that's what we're going to talk about in the more practical piece, which we'll get into in just a second. Again, we're still doing background baselining, talking about what some of the challenges are, just trying to expose what it is. But now we get to focus on what we can do to help fix this. And I want to go back a little bit first. This is not new. HTTPS inspection has been in Check Point for a long time, but that cert issue hasn't changed significantly either. Ultimately, I have two primary methods if I want to do my inspection with my Check Point gateway, which is now we've jumped to that assumption that we're talking about existing Check Point firewalls at the perimeter, performing your firewall inspection, and ideally, hopefully soon, performing some degree of HTTPS inspection as well. When they do so, they're going to be that man in the middle. If we don't want our users to complain that the certificate is not right, we ultimately have to have the gateway using a trusted certificate. And it's not so much a trusted certificate per se, but a trusted certificate authority, because what's going to happen is when the user tries to go to Gmail, they typed it correctly, and the firewall sees the traffic going to Gmail, and it's by policy going to inspect the traffic. The gateway is going to terminate the connection at the gateway, deliver a certificate to the user. And since we don't actually own Gmail certificates, we can't pull their certificates and deliver them correctly and authenticate a connection, again, because this mechanism works the way it's supposed to, we have to give them a different cert. And that cert can be from the gateway itself. We can create that certificate when we enable HTTPS inspection on the gateway and say, yes, here is the certificate for the firewall. The user can get that certificate from us, but their browser is going to say that's not a trusted cert. That's a bad cert. It's a self-signed cert. It doesn't match what we're connecting to cert. It's, for any number of reasons, not going to make their browser happy. Way around that, if we're creating that cert itself, is to deploy that certificate, which we can export, which will be later down in this screen that you're not seeing here, to export that cert and deploy it potentially via GPO or any other mechanism you have to, again, your trusted managed computers. You could put this out there for students as well who have their own machines, and you know, if you're blocking their traffic, if it's not using the proper methods, you could theoretically allow them to deploy the cert themselves. The key, however, if we're talking about even just a subset of our users, a smaller group, which is what we're going to focus on in the next couple of slides, we have a defined known group of machines that we want to be inspecting, and we have access to them, administrative access, their domain computers, for example. We can import that cert or export that cert and publish it and push that to all of them via GPO. It's not that difficult. I'm not going into that here. I've done that in the past. We can talk about that offline. Happy to show that. Again, it's pretty well documented. The key here, and where I often see it messed up, is when you deploy that cert, even if you're just doing it on your Windows machine for testing, you want to kind of deploy the cert locally to see if inspection works well or not. And we'll show you how you can do that safely. The key is not to let that cert be imported by Windows into the default or automatically detected certificate store. The key is to deploy it as a trusted root certificate authority. It's not a web server cert. It's not even a wildcard cert. It's a cert that's going to sign other certificates or on behalf of other sites. I'm saying, yes, I'm Check Point, and I am certifying that you are connected to gmail.com. So it's a special kind of cert that's used. If you get it in the right certificate authority, you take that exported cert, deploy it as a trusted root certificate authority, it can work, and it can work really, really well. Again, we'll talk about more details on how that works in a second. The other way to do this, however, is to use an already trusted certificate. If all of the machines you care about inspecting are members of a domain, they're domain computers, they trust your domain. They therefore trust your CA in your domain. You can export or create a cert from the Microsoft side and use that cert instead. Again, the trick here is when you go to the cert guys or the server guys, if you're the server guy yourself, great. The trick is do not generate a website cert or a wildcard cert. It's a little bit trickier than that and much less common. We need to generate a cert for Check Point to use that is, again, a trusted root certificate authority. We're saying he's able to sign on behalf of anyone. So that's kind of the preface to this, getting the certs right. It's very doable. However, as we said, it's not perfect. There are sites that simply will not work. Banking sites, for example, will verify not only that they're getting a good cert that your browser trusts, but that the application itself trusts. They're going to verify that they're using the right cert, not just a good cert, but a great cert. So let me get into what's changed and what we can do now that we couldn't do in years past. The first one, we talked about this back when we did an overview.
Hey,
yes.
Eric, can you go back? Can you go back to the other slide?
Sure.
Yeah, so the alternative here, right, is that you can use your own internal CA if you have one, right, to deploy, to generate the certificate, and it makes deployment easier because your clients, your users on the domain already trust the domain control, the certificate authority, because it's automatically installed on the client that's part of the domain. So the alternative here is that instead of using the self-signed certificate from the manager, to use your own internal CA, create a subordinate CA certificate, and then you don't have to touch the client at all.
Right. That's what I was getting at in the second bullet. It's instead of having to tell them a new cert they trust, use one they already do, or use the CA they already trust. Exactly.
Yeah, and it's
you're not touching the endpoints that way. It's a little trickier to get that cert from the server guys if they're not you. But
right.
But once you get that subordinate cert installed, you're not touching endpoints, which again is the whole idea.
Yeah,
of doing
and the key is that as you're going into this, you want to make sure that you pick either or, because once you generate this certificate, you actually have to go in and there's a DB edit modification that you have to do in order to replace the certificate. It's not through the GUI. So
very, very good point. And if you've ever done this, you've seen once you click one of these buttons, they go away. The ones that I circled there, create or import, once you click it and do one or the other, it's not as simple as just go back and say, oh, no, I want to go the other way. It's doable, but yeah, good point, Juan.
okay,
thank you.
That's all I had.
All right. So back when we did a webinar on what was new in R80.40, one of my biggest, I think it might have been my drum roll, please, my final item was this change that was made that had been a problem before. And to illustrate why it was an issue, prior to R80.20, Check Point had URL filtering and app control and HTTPS inspection. If we didn't want to perform inspection because of the issues it causes with certificates and with sites breaking, which we know is an issue, we're going to talk about how to deal with better now. If we didn't want to do that, there was this ability, and still is this ability, to perform categorization of HTTPS sites. This would allow you potentially to perform URL filtering without being a man in the middle, without breaking HTTPS. And this is because, if you remember back when we discussed about what HTTPS does, it doesn't necessarily encrypt everything, especially in earlier specs with SSL and earlier TLS. There are some pieces that have to be in the clear. The IP addresses are one piece. IP addresses will always be in the clear. Your source and destination IP we can see. We can't encrypt that unless we have a real tunnel. But when I'm connecting from a client to a server, IP addresses will be in the clear. There are pieces of the negotiation in any encryption negotiation that are exposed. They have to be, because I can't just start encrypting with you with encrypted traffic. We have to negotiate the encryption. Some of that's in the clear, and some of what ends up being in the clear is often the URL. Not sorry, the URL, but at least the domain name. Who's negotiating this cert, or on behalf of who? I might see google.com in the name and know that, oh, okay, you're establishing a connection to something at Google. Maybe even better, it's Gmail, and I see Gmail. This is a cert that you're requesting, and a site that you're communicating with certs for gmail.com. Therefore, I know this is a webmail site. If I want to have a URL filtering policy that leverages that, I can do so. I could say, yes, you're allowed, or no, you're not. And you may have, without doing any inspection at all, without enabling that checkbox, been using categorization and had a URL filtering policy that leveraged and needed that categorization. And that was fine. The problem was, prior to 80.20, when you then enable HTTPS inspection, it would disable that categorization, because the theory was, if you're inspecting, if you're actually breaking apart HTTPS, you don't need to do that HTTPS light, as it was often referred to as. We don't need to do that. We're just going to look inside. The problem becomes, in the real world, when we would deploy HTTPS inspection, initially we want to limit it to a small subset or test group to make sure that we work out kinks and that we find the exceptions we need. It's very similar to what we've talked about in the past deployments of IPS. You can't start blocking everything that you think is bad, because you're going to have some false positives, potentially false negatives. It's a working process. And that's what happens with HTTPS inspection. Getting this policy developed requires a little bit of effort. And in the meantime, we're going to bypass inspection for most of our user population. And if we're bypassing inspection and we're not able to categorize, now our URL filtering policy is basically rendered defunct. And that caused a lot of grief for people prior to R80.20 that were using that categorization. So one of the biggest pluses in 80.20, they can coexist. Picture one of those nice little graphic icons, coexist bumper stickers. You can have categorization enabled and still have your URL filtering policy be active, but also take advantage of inspection. The other piece, and I actually had that image popped over out of order, with 80.40 now, biggest simple sounding change is the fact that our policy for HTTPS inspection is now a layer. So this is the biggest issue. I mentioned 80.40 has given us a lot. It seems simple because it talks about one simple concept here: layered policy. It is a specific policy for HTTPS inspection, like it was before, but this was in dashboard. This is not. In its simple sense, it means we don't have to go to dashboard to do this. We get our own policy. It's actually a layer, or multiple layers, or I should say different layers, selectable layers, that we can apply to our gateways. And this again requires gateways to be 80.40, not just management, of course, management as well, but then the gateways to be on 80.40. But now we can use all those other cool new types. This is where I'm really going to focus. This is the piece I want you to all see and pay attention now, because this is stuff you can do. 80.40 is out. It's trusted. It's been out a long time. There's a number of hot fixes available to get it very, very stable. And it is the most common that we see out there in production now. And you have this ability if you're on 80.40. What it affords, not only is it layered, but we have multiple layers. In dashboard, we had one HTTPS inspection policy for our entire management deployment. Now we have this in a layer, which we can have multiple versions of it. We can have different HTTPS inspection layers applied to different policies, therefore applied to different gateways. We can architect them separately. We can have one for a test lab, for example, that's different than for production. That was a challenge before. So we have different policies, and in its simplest sense, we don't have to go to dashboard. We can architect this policy entirely in Smart Console. No more launching dashboard, waiting for it, chewing up more resources, more RAM. This policy, which I'll break down into its elements as we go, is, as you can see here, right in Smart Console. One less reason now we have to go to Smart Dashboard. One of the biggest pieces of this and biggest advantages to that layer, however, is that our bypass, which is really where I'm going to focus, is much more effective. when we're first toying with HTTPS inspection, and I'm not going to get into, as I mentioned, the underpinnings of how it actually works, why some sites work, why they don't. The bottom line is some sites either can't be inspected or shouldn't be inspected. There are many reasons we may need to or just want to bypass inspection on certain sites, whether it's because of high volume, it's killing our performance. We send a lot of very sensitive data to these sites, or maybe it's not even that sensitive, but it's high volume, and we trust them. We don't need to inspect that. That's our, one of our sister companies. We know they're good. We're just doing way too much work decrypting and re-encrypting that traffic with inspection. Maybe we want to bypass just because of that. It's just too much effort and it's not really necessary. Maybe it's because of compliance. We aren't allowed to inspect certain traffic. Government contractors, others that need to maintain that privacy. Or again, certain sites just don't work. All kinds of reasons we may want to bypass inspection. That's really the key here when we talk about getting that policy to work properly. How do we bypass it? The biggest challenge has been identifying that traffic and knowing that we need to bypass it. If I'm doing it via URL, it's a challenge. If I say I want to only block games.facebook.com, the cert negotiation with HTTPS categorization only sees that it's Facebook. I can kind of all or nothing URL filtering Facebook. If I want to do effectively app control, I have to actually do inspection. I have to get in there first before I see what it is. And that's part of the challenge. Knowing what the content is requires opening it up. So to do true app control, I have to at least peek. And by peeking, I may have actually broken the site. More ideally, if I could base my decisions of what to inspect and what not to inspect on IP addresses, now I don't have to worry about that. Because as we said, the IP addresses are going to be exposed. I'm going to see the IPs. I don't have to break it open to see who's talking to what from a source and a destination IP perspective. Hold on, I need a sip. And yes, it's just water. If I can base my decision on IP addresses, that's a much better situation. So we're going to start with our most common rule, our initial bypass rule. When we start dipping our feet into HTTPS inspection and checkpoint, one of the first recommendations is to turn off inspection for everyone except the test group. And when I say turn off, I don't mean turn off, I mean bypass. If you're not one of the people I've reeled into and roped into testing HTTPS inspection for policy for us or for me, I'm going to bypass you right at the top. Now, that was a problem before, because how do I know who that is? The effective way to do it previously would have been with static IP address objects. I could put a host object in. In my example here, also, forgive me, I'm using one of the more advanced techniques. For some people, it's great if you understand the logic behind a negate. This is a very effective rule. If you don't, there's other ways to work around it. But the idea here is I'm saying in the rule, if the source is not one of my testers, and here the beauty is because we're in Smart Console now, I'm using an access role, not a host object or a group of host objects. I can say if you're not in this role, we bypass you. You're out. Well, who is in this role? Well, access roles, as you might recall when we talk about identity awareness, can be made up of machines. And in this case, I have my inspection testers role locked down to only domain computers, because I know all the guest machines and non-domain machines, we definitely don't have the certs deployed on them, or they're not using the same CA. So I know they're going to be a problem at first. So for now, skip them. But also, the inspection testers are only these people. Maybe I only put these certain users in that group. Again, using my Active Directory connection within my identity awareness, I say that only these people are in that group. I could put myself in here to start. Could be whoever I want. I could also use groups and OUs to define which users we want to actually inspect for. Now, the beauty is this group can very easily, from within Checkpoint, within Smart Console, be expanded as I add people from different departments, different areas that I want to test for me. The beauty of this is identity awareness, if you don't recall, ultimately is a list of IP addresses. Because it's based on IP addresses, not really the user's name, because the traffic itself doesn't have the user's name in it. Because it's basically a list of IP addresses, this is used in the source of a rule, and it's matched based on the source IP of the packets. So if the IP address I see you coming from happens to be Marcellus's IP address. I see that in this rule, and I know it's not being bypassed because of that, because he is one of my testers. We don't match rule 1. We're going to go down to rule 2. If you're not one of those people in this role, based on your IP address right now, you're going to be bypassed. And that's an effective bypass that allows us to turn on inspection with 8040 without that fear that we had from years past of breaking things for a large group of people. And that's really what it comes down to. One of the main things, I'm going to get into a little more detail here too, but if you had tried deploying HTTPS inspection in the past, that was one of the biggest issues, is it didn't really allow bypasses to function the way we thought they would, or the way we wanted to. It's gotten much better. That ability to bypass with a role is huge for the initial stages. And bonus points to whoever sees a common theme in those names. I'll give you a second on that. This also means when we get into our production rules, we can use roles here as well. We can say, for example, that if the machine, and ultimately what we typically will do is this policy, which we'll look at it again in its entirety in a minute. First rule is bypass for anyone who's not testing. That's a temporary rule until we get all the kinks worked out and we have a good bypass policy, good HTTPS inspection policy set up. The first rule we'll likely have, or we may have in our production policy, is to not inspect non-domain machines. We may also limit where they can be, what they can do. In our security policy, we may have limits as to what they can access. But the idea is if they're going to break when we try and inspect them anyway, maybe we bypass them. Maybe they're in a guest group coming from other exposed wireless guest VLANs and so forth. But that's one example of a rule we can say, yep, if you're not in my domain, I'm not going to bother. But all of our domain machines, I know have the cert, or we trust the same CA. We're using a subordinate cert that they know about. So we're going to let them continue on to rule 3. Again, this could be a simple OU of all my domain PCs. It could be more specific if we want to, again, using access roles, which are IP addresses, which means we don't have to do inspection just to figure out if we want to bypass. The next really cool piece here is those updatable objects that were introduced actually in R80.20. If you remember that, we talked about those when we did a webinar a while back. Was it last quarter, July, maybe, on R8040's new stuff? Sorry, when we did the R8020 new stuff. Well, R8040, I revisited it because those updatable objects continue to expand. They continue to add new ones. Updatable objects, as you recall, are things like the services you see listed here. This is lists that are maintained by Check Point, actually maintained by Check Point with other providers like Google, Zoom, Okta, Amazon, Microsoft, you name it. They're maintaining these lists that are publicly accessible. I'll show you how we can get more detail on it in a second. But the idea is that I can reference these in the destination column as IP addresses, because that's what these are. These are lists of IP addresses that are constantly updated without doing policy installations to reflect all of the IPs within S3's US East 1 list from Amazon. Whatever objects you see, and I'll show you another example of this in a second. I can put those updatable objects in here, and because they are basically resolving back to IP addresses, I can have my bypass be very effective. It does not have to break in to SSL, HTTPS to know that it needs to bypass. I'm bypassing it based on the destination IP you're going to. Using those updatable objects is huge, making sure that we can bypass stuff that we really, really should or need to bypass. So another thing I will tease, one of the things coming in R81 is custom lists like this. The ability to either maintain your own or add in other third-party XML type formatted lists of IP addresses. It's been talked about. I don't want to guarantee anything there. I'm not going to say it anymore. I'm not going to repeat myself. Can we edit that out of the recording? Because I don't like to make promises for things that are potentially coming down the road, but this is something that could be extended to allow beyond what we see. But they're also constantly expanding this list of what's available in updatable objects. We can simply add them in here. Along with updatable objects, if you recall from that webinar of what's new, we talked about other dynamic objects like data center objects. When you have tied in to cloud providers and other providers like you see on the list that I left highlighted on the right there, we can be pulling objects from them, object groups and types and categories from them as well, and using those in our lists of bypasses, as well as IoT controllers. That's a fun one. We talked about that on one of the last webinars as well, where integration with IoT controllers allows us to create our own groups based on potentially categories and criteria of IoT devices within our environment. We could say that these particular devices or devices that have this capability should all bypass inspection because we can't deploy certs to them. Another good category or type of bypass you might want to create that can be maintained automatically and be done again at the IP address level. Here, I knew I had a screenshot showing kind of a more current list of the updatable objects categories and types. A lot of these have subcategories. You can kind of dive deeper. You'll see Check Point is actually maintaining some themselves here for things that they recommend be bypassed or that are very commonly requested. So under the HTTPS services bypass, you'll see some examples, and they continue to add and expand what's in there as well. You'll also notice most of these have links to their actual info pages of where these lists come from. Some of them will link out to a Microsoft page that says, here's the current list of IPs or networks, and more information on how to retrieve them. In this case, this is a Check Point maintained list. So of course that detail all comes up in an SK. It gives you an idea of what this list is about, what it's for, how it's maintained, and so forth. And then of course, there's an example of one of those IoT devices. I captured the screen from my last presentation, but those can be used in here in bypasses as well. Kind of funny, I'm getting into health equipment talking about bypasses. Ultimately, this is what our bypass policy might look like now. All of these new things we see in source and destination are really the big improvement, one of the big improvements in 8040 that makes this more possible and capable for us. To be able to make decisions based on the IP addresses, as opposed to what we see in the later rules 4, 5, and 6 that do require a little bit of digging in, or at least categorization of the URLs in order to make that bypass work. I've gone over, I'm so sorry. There's a lot here. I love to, everybody knows I can talk, I can go on further. I'd love to talk more. I'd love to answer questions. I don't see many. I see one that I'll address in a second. I know a couple came through and were answered. We're always happy to talk to you. Definitely engage. Let me go right to the final slide here. I want to put up, if you've done any of this, if you've had trouble with it, or if it's worked well for you, whatever you've done, I'd love to hear from you. Reach out to me directly. Reach out to your other contacts at Atlantic Data Security, whether it's technical or sales. By all means, reach out, make this interactive, talk to us more. Tell us what you'd like to see. If you have challenges here, what can we do for you as a team? We've got a big group of very good guys and gals who are very able to help with this. It's not I showed you, it's done, good luck. No, reach out. We'd be happy to work with you, show you more, show other people in your organization if you want, if you'd like us to revisit this or go into a different angle. By all means, reach out to me directly, reach out to others in our group, whoever you know, whoever you're comfortable with at Atlantic, and we'd love to hear from you soon. But I will zip it for now and see if there's any questions I can answer. Let's see, there's one. There's a lot of bad links, and this is another issue. We talked about what the threats are within HTTPS. There's a lot of stuff that comes through, and I think I've seen percentages of 90+ that attacks and malware come through email. And it's not the actual malware itself. It's not necessarily the payload, but links. It's, phishing links are really just links. It's something that you try and get easy to click on. When they click on that, they're going somewhere that will eventually potentially infect them, pulling down bad content. How can we stop it? Well, if we look at the content itself, that's fine. If we can look at the URL and know where they're going, that's okay. Or if we can do it by IP address, and threat prevention in Check Point and other products use those methods. Outside of actually stripping the email itself or identifying the links in the email and getting rid of it, which we can also do via various methods, stopping the content to those sites is really the key, or identifying the content as it comes down from those sites. They are trying to use cloud providers. They're not spinning up their own web servers with easily identifiable foreign IP addresses. They're doing things to make it look like it's coming from a trusted site that we have to bypass inspection for. But ultimately, it comes down to doing what we can and inspecting as much as we can to be able to make informed, valid, and comprehensive decisions on it. Answering the question, the setting in 8020, let me go back to the slide for you. The setting that was introduced, it wasn't a new setting in 8020 that was introduced. It was, the issue stemmed from the fact that, which slide was that? Prior to 8020, well, let me go back a few more. The issue was that if we enabled HTTPS categorization to basically allow URL filtering to work on encrypted sites by kind of peeking in the cert negotiations, the back and forth, if we had that turned on and we're using that to do URL filtering without having turned on inspection, that was fine. But before 80/20, if we then turned on inspection, this was effectively turned off. We couldn't have both inspection and categorization working together. The reason was simply that Check Point figures if you're doing inspection, you don't need to do categorization. Let's not waste our time. The reason it was a problem is if we turn on inspection, but then have our bypass say, yeah, we bypass for almost everyone while we work out the kinks. We have a very limited test group. Now, all those people we're bypassing inspection for also aren't getting categorized. And that's what wreaked havoc on our URL filtering policies. So now if we had depended on that categorization to get good URL filtering, that was the problem. This setting is under, this one I don't have a screenshot for you, but it's under blades. When you go look under, I don't have demo mode running either. I'm happy to do it. I'm happy to go over. And anyone else, if you have questions, great, stick around. I'd love to field them. I do have time. I think I was supposed to be on a call, but I'm not primary, so I can answer some more questions. Let me pull up demo mode and actually show you where that is, but it's under your managing settings, under blades, under HTTPS inspection. There are some settings in there, and that's where you'd find this categorization to turn on or off. In previous versions, it would be under the HTTPS inspection settings, I believe, in Smart Dashboard, if that helps answer the question. So let's see, any other questions? Comments, thoughts, ideas? You're welcome. It wasn't really a question, but I'm happy to answer it. I am still pulling up my demo mode. I usually have that ready before I start presenting. Sorry, guys. All right. Well, thank you all for attending. Again, I'm not leaving just yet. How can we replace SSL cert? That's something we'll take offline. If you've done this using the Check Point generated cert and you want to replace it with one that is trusted by your users, as Juan had mentioned, that's a little bit more of a process. Involves a little DB edit to be able to get in there and actually look at it. And that's something I don't necessarily want to show a wider audience right away, but let me show you where that setting is first. Under managing settings, under blades, under HTTPS inspect. Oh wait, no, sorry. Where was I going with that? I went to the wrong place. I confused myself. Here we go. App control and URL filtering. Here's that categorization right here. So that's where you would turn on that categorization or turn off that categorization. Typically now, not a reason to turn it off. Again, unless it's breaking certain things. But there's that. Yes, I believe the recording will be available. Usually is. Go ahead and reach out to Donna or whoever you got the invite from in the first place, and that will likely be made available to you. But yeah, as far as replacing the SSL cert itself, as Juan mentioned, the issue with that, I'm just addressing the only other question I still see. When we're looking at a particular gateway, when we enabled HTTPS inspection initially, we had that choice to create or import. Once I say create or import, I give it my information. Create, yeah. Sorry. That's what happens when I try and use a weak key. Once I hit create, those buttons go away. And now it's self-generated and spun on another screen. It's self-generated a certificate for me. And now my only immediate means is to take that certificate, export it, and then deploy that to my users, to my machines that I'm going to be inspecting. If I wanted to go back and be able to import a cert that was created elsewhere, that's where I have to go into DB edit and do some little dancing to work around and come back into this and import that cert. You'll also see, just to go back to this. And I think I actually have to go to dashboard for this. The other thing that doesn't come up often, but is still possible, is inspecting inbound traffic. The fact of the matter is inspecting inbound traffic is in many degrees easier, simply because our own web servers, we have the certs for. We can take our own certs for my website that's hosted internally, and I can take that cert and actually import that into Check Point and say, for access inbound to my site, use my cert. So while it's still done and we do still see inspection happening on an inbound way, it's often either, I don't care if remote users are secured or not. I'm happy to infect them. I don't care. If that's your philosophy, you're not worried about inspecting the inbound traffic to your own sites. But if you are and you want to deal with it, then under our HTTPS inspection, we can see we have other certs here as well. And this is not new. This has been in HTTPS inspection as far back as I can remember. But the idea here would be, yes, and if you didn't see it in the comments, Tim posted that, yes, the recording will be up on YouTube at some point, hopefully before long. We can add our own server certs if we have them. We can have our own certs thrown right in here. And then within our policy, which, since I'm doing this now in 8040, my policy is here. Within my policy, I could have rules that dictate or control HTTPS inspection of traffic to my servers. I could say any traffic to a destination of my web server. Replace internet with, I think there's a web server in demo mode here. To my web server. The idea here is I use a different cert. And if I had deployed or imported one of my certs in dashboard, I'd see that here. So I would take my web server cert, import that, and then say, for traffic to my web server, use the web server cert. And now you don't have cert violations because you're actually using your own cert somewhere else. Just another little side note. Anything else interesting I can show anyone? All right, well, if not, I'm sure some people are off getting lunch or just sitting back or clicking on something else. So I'm not going to wait for everyone to disconnect. I'll say thank you again for attending another Support Aware webinar. Hopefully you got something interesting out of it. Again, keep the feedback coming in. Let us know if it hit home at all, was interesting, useful, or what else you'd like to see, or if you'd like to continue the conversation outside. So thank you all, and stay safe, stay well, and we'll see you next time.